All right, this is section 4.3. By the end of today's lesson, you should be able to evaluate trig functions of acute angles, use the fundamental trig identities, and use your calculator to evaluate trig functions. So if I look at this first slide about the right triangle definitions of trig functions, let theta be an acute angle of a right triangle. Then the 6 functions of angle theta are defined as follows. So sine, it's your SOHCAHTOA essentially. So sine of theta is going to be opposite over hypotenuse. So then cosecant of theta will be its reciprocal. Cosine of theta would be adjacent over hypotenuse. So secant of theta is going to be its reciprocal. And tangent of theta is going to be opposite over adjacent. So cotangent of theta is going to be its reciprocal. So if I look at this first picture here, it says find the exact values of 6 trig functions of the angle theta shown in the figure. Okay, well, I'm going to need all 3 sides in order to figure out the 6 trig functions. So hopefully you're thinking to use the Pythagorean theorem to find the third side. So to use the Pythagorean theorem, I'm going to say hypotenuse squared equals the leg squared plus leg squared, or c squared equals a squared plus b squared, however you want to think about it. So in this case, 4 squared equals x squared plus 2 squared. 4 squared is 16. X squared, here I get 4. So when I subtract, I get 12 equals x squared. So when I take the square root, that doesn't come out evenly. So what's the largest perfect square that goes in? Well, that'd be 4, so this would be 2 root 3. Okay, now I can list all 6 trig functions. So I can say sine of theta is going to be opposite over hypotenuse. So this is going to be 2/4, which is 1/2. So its reciprocal cosecant of theta is just going to be 2. 2 over 1, which is just 2. The cosine of theta is going to be adjacent over hypotenuse, which 2/4 reduces to just 1/2. So this is going to be square root 3 over 2. For secant, I'm going to get 2 over square root 3. So I'm going to have to rationalize quickly here. So this would just be 2 square root 3 over 3. Tangent, opposite over adjacent. So that's going to be opposite is 2 over adjacent, which is 2 root 3. So I get 1 over the square root of 3, which we'll have to rationalize. So we'll get square root 3 over 3. And then cotangent of theta would be the opposite. So if I knew 1 divided by 3 was tangent theta, this is just going to be root 3. Okay? So looking at the next problem, it's the same kind of thing. Sketch a right triangle. Oh, this time they don't give us the right triangle. To this corresponding trig function of the acute angle theta. Use Pythagorean theorem to find the third side, then find the other 5 trig functions. Okay, let's draw a right triangle. So if I put theta here, so cotangent of theta equals 5, so that's adjacent over opposite. Because it's essentially the reciprocal of tangent. So I'm going to say, okay, that means that this is really 5 over 1. So this is adjacent is 5 and opposite is 1. So we have to do the Pythagorean theorem. So we don't know the hypotenuse here. So I'm going to say x squared equals 5 squared plus 1 squared. So that's going to be 25 plus 1, so that's 26. So the hypotenuse is going to be square root 26. All right, so let's look at the trig function. So the sine is going to be opposite over hypotenuse, so that's 1 over the square root of 26, which hopefully you can rationalize really quickly to get the square root of 26 over 26. So the cosecant of theta would just be the square root of 26, its reciprocal. Cosine of theta is going to equal 5, the adjacent side, over the square root of 26, the hypotenuse. So this is going to equal 5 square root 26 over 26 after I rationalize. And then secant of theta would be its opposite, so that would just be the square root of 26 over 5. Tangent, opposite over adjacent, so that would be 1/5. And cotangent would be, cotangent of theta would be adjacent over opposite, so that's 5 over 1, which is just 5. Don't forget your trig table where they sing that lovely song to you, 1, 2, 3. That's going to be extremely helpful for numbers 17 through 26 on your homework. Something new is cofunction identities. So if I know I have the sine of 90 degrees minus theta, that's the same as cosine theta. If I have cosine of 90 degrees minus theta, it's the same as sine theta. If I have tangent minus of 90 degrees minus theta, that's cotangent theta. If I have cotangent of 90 degrees minus theta, it's the same as tangent theta. If I have the secant of 90 degrees minus theta, that's the same as cosecant theta. If I have cosecant of 90 degrees minus theta, that's the same as secant theta. Alright, so if I look at this next problem, it says, use the given function values in trig identities, including cofunction identities, to find the indicated trig functions. Alright, so I'm given secant of theta equals 5, and tangent theta equals 2 square root 6. So cosine theta, well, that's just going to be the reciprocal of the secant theta here. So I know that this is just going to be 1 over secant theta, so that would be 1 over 5. Cotangent is just the reciprocal of tangent, so that's going to be 1 over 2 square root 6. And then when you rationalize, you get square root 6 over, well, that's just 6, so times 2, so that would be 12. Now I have a cofunction identity, so the cotangent of 90 degrees minus theta is going to be the same as tangent theta, which we know is 2 square root 6. Alright, now we have sine theta. Well, there's no relationship that we know of yet using just these cofunction and reciprocal identities. So I'm going to look over here at my fundamental trig identities and see what would kind of help. Well, I know tangent, I know cosine, so I'm going to use this quotient identity where the tangent of theta equals sine theta divided by cosine theta. So the tangent of theta equals sine theta over cosine theta. And that makes sense because sine is opposite over hypotenuse, tangent is adjacent over hypotenuse, so essentially those hypotenuse cancel out, so you're left with the opposite over adjacent. So let's plug in what I know. I know that the tangent is 2 square root 6. The sine of theta is unknown. The cosine is 1/5. So on the right-hand side, this is really the same as saying sine theta. So that would be, instead of dividing by 1/5, it's 5 times the sine of theta. So I can divide both sides by by 5. So sine theta would equal 2 square root 6 over 5. Alright, so now something that's going to be important to kind of memorize, even though most of them should be very natural to us. The reciprocal identities, we should know that the sine of theta is the same as the 1 divided by the cosecant of theta. Essentially, it's reciprocal. Same with cosine and secant. Tangent of theta is 1 divided by cotangent theta. And then just the exact opposite. What's kind of newer to us was these quotient identities. Tangent theta equals sine theta divided by cosine theta. And then the opposite rings true. Cotangent theta equals cosine theta divided by sine theta. The last are not as familiar. So we would have sine squared theta plus cosine squared theta. That actually equals 1. 1 plus the tangent squared theta equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. And we could kind of manipulate these around and use them as we need to verify trig identities. So when we're trying to verify identities, we're trying to get the same thing to be on the left-hand side of the equation to be on the right. Here are some tips. Try changing everything in terms of sine and cosine. Combine it in a single fraction. Maybe you have to get a common denominator. Maybe split fractions. Or factor. So try all these different methods if you are stuck on verifying trig identities. So if I look at this first problem, it says use trig identities to transform the left-hand side of the equation to the right. So if I look at my first identity here, I have cotangent alpha sine alpha, and I want it to equal cosine alpha. Alright, so I'm going to use that first tip about writing everything in terms of cosine and sine. So this cotangent alpha, I'm going to rewrite that as cosine alpha over sine alpha. And that's being multiplied by sine alpha. So if I look just by rewriting that, do you see how the signs cancel? So do I have what's on the left-hand side equal the right-hand side? Yep. So I have verified this trig identity. I'm sorry, Alright, so now, example 5. Sine squared theta minus cosine squared theta equals 2 sine squared theta minus 1. So I want to transform the left-hand side to equal the right-hand side. So, if you notice, you kind of have to look at what you need. I'm going to want two sine squared thetas. Right now I only have 1. So is there a way to transform this cosine squared theta to give me another sine squared theta? Well, if you look back at our trig identities, our Pythagorean theorem identities, can't I kind of rearrange sine squared theta plus cosine squared theta equals 1 to be in terms of just sine? So I could say cosine squared theta is the same as 1 minus sine squared theta. Do you see how I just kind of rearranged this identity? So now I could take this and plug that in for cosine squared theta. So I would get sine squared theta minus 1 minus sine squared theta. And we would just have to do a little distributive property here. So I get sine squared theta minus 1 plus sine squared theta. And if you look, now I can combine like terms because I have 2 sine squared theta, so that's going to become 2 sine squared theta minus 1. So now the left-hand side has been transformed to the right-hand side. All right, so if I look at this last, it says use identities to transform the left-hand side to the right-hand side. So now I have tangent beta plus cotangent beta divided by tangent beta equals cosecant squared beta. So I'm going to actually use a couple of these tips. First, it looks like we need to get everything to be in terms of sine and cosine, because on the left-hand side I have tangents, on the right-hand side I have cosecant. So somehow that becomes the reciprocal of sine. So I'm going to say, okay, here this is going to be sine of beta over cosine beta plus, and then the cotangent would be the opposite. And that would be over cosine, so that's, I'm sorry, the opposite of tangent beta, so that would be sine beta over cosine beta. All right, so things need to get simplified. So let's try and get one fraction in the numerator. So I'm going to multiply to get the common denominator, this by sine beta, and this by cosine beta. So now this numerator will become sine squared beta plus cosine squared beta over that denominator. Well, hopefully you're looking at your identities and saying the numerator would just become 1. I'm going to move it up here. So this is essentially 1 over sine excuse me, I forgot the denominator here. Let's go back here. So we have sine squared beta, sine squared beta plus cosine squared beta over the common denominator. Hopefully you caught that. And then that's over sine beta divided by cosine beta. Okay, take a second and look at that. All right, so now I can look and say the numerator is going to be 1. The denominator will stay the same for right now. And it's being divided by sine beta over cosine beta. So I'm going to flip here. So I'm going to leave the first fraction alone. Change to multiplication, and then essentially flip the second fraction around. So if you notice, my cosines cancel. So I'm left with 1 over sine squared beta, which, lucky for us, equals cosecant squared beta. All right. Here's your homework for the weekend. Have a good weekend, and I'll see you on Monday.